NASA telescope confirms 3I Atlas is far larger than expected.
NASA's latest alert has sent a chill through the scientific community and beyond. The announcement concerns the interstellar object 3I/Atlas, an enigmatic body traveling through our solar system, which recent calculations suggest could be on a path intersecting dangerously close to Earth. Unlike ordinary asteroids originating from within the solar system, 3I/Atlas is part of a much rarer class: interstellar visitors that cross into our region of space from the depths of the galaxy. The very nature of such objects makes them difficult to track and predict, but the fresh data fueling NASA's red alert has underscored a potential scenario that no one had expected to materialize so soon. Before we start, smash the like and subscribe buttons for more updates. From the beginning, 3I/Atlas stood out as an unusual discovery. Astronomers initially detected it as a faint speck moving against the background stars, but its velocity and trajectory revealed that it did not belong to the solar system. Instead, it was just the third interstellar object ever cataloged, after the mysterious Oumuamua and the comet Borisov. These bodies are thought to be remnants of planetary systems forming around other stars, ejected into interstellar space before wandering for eons. To have one of them arrive in Earth's neighborhood is already extraordinary. But the fact that NASA's latest computations link 3I/Atlas to a potential impact trajectory elevates the stakes to an entirely new level. The designation of Red Alert is not made lightly by NASA. It reflects not only the potential danger, but also the uncertainty in modeling the motion of such fast-moving interstellar travelers. Unlike comets and asteroids we know well, whose orbits can be refined with decades or centuries of observation, interstellar objects give scientists only a fleeting window of data before they move beyond detection. The measurements show that 3I/Atlas is carrying immense kinetic energy due to its speed, far higher than most local asteroids. If Earth were to be in its crosshairs, the consequences would defy imagination. Even though its size has not been firmly determined, estimates suggest 3I/Atlas is at least several hundred meters across, potentially even larger. An object of that magnitude entering Earth's atmosphere at interstellar velocities would release energy far surpassing any nuclear arsenal ever assembled. The comparison often used by astronomers is that such an impact would equate to tens of millions of megatons of TNT, unleashing a global catastrophe. The sheer force would vaporize the impact site, send shock waves through the atmosphere, and loft vast amounts of material into the stratosphere. The chilling part of NASA's latest models is that there remains no certainty that the Earth will be spared. The behavior of interstellar objects compounds the difficulty. Because they are not bound to the sun's gravity in the same way as native asteroids, their trajectories curve in unpredictable ways when they interact with the solar system's massive planets. A tiny gravitational nudge from Jupiter, for example, could dramatically alter the path of 3I/Atlas, potentially steering it onto a collision course with Earth. This is precisely the scenario scientists are running simulations on now, watching for possible resonance points and orbital perturbations that might funnel the object closer to our world. Adding to the fear is the speed. Local asteroids average around 20 kilometers per second relative to Earth. 3I/Atlas, by contrast, is hurtling through space at more than double that rate, with some models putting it closer to 50 kilometers per second. At that velocity, even a smaller fragment of the object would carry devastating consequences. Unlike slower-moving impactors, which might burn up more fully in the atmosphere, an interstellar object retains staggering amounts of energy to deliver upon impact. NASA's Red Alert, therefore, is not hyperbole. It is a recognition of the unique threat profile 3I/Atlas represents. The psychological dimension of this alert cannot be overlooked either. Humanity has grown accustomed to hearing about near-Earth objects and the monitoring programs designed to keep us safe. Hundreds of telescopes scan the skies nightly, cataloging potential hazards. Yet, in all of these systems, interstellar objects represent a wild card. They appear suddenly, streaking into visibility with little warning, and their origins beyond the sun's dominion make them resistant to long-term prediction. The unsettling truth is that if 3I/Atlas is indeed on a path toward Earth, humanity might not have the luxury of decades to prepare. At the core of the alert lies a paradox. Although NASA's data is terrifying, it is also incomplete. The uncertainty bands on the trajectory stretch wide, leaving room for both harmless passage and direct intersection. Astronomers are racing against time to gather more observations before 3I/Atlas slips farther along its trajectory, where it will grow fainter and harder to study. Each night of telescope time becomes critical, as refinements in the orbital calculations could spell the difference between reassurance and disaster. The tension lies in that narrowing window for clarity. Speculation abounds among the scientific community. Some argue that 3I/Atlas could pass safely at a distance measured in millions of kilometers, brushing past Earth's orbit in cosmic terms but still sparing us. Others are more cautious, pointing to subtle variables that could compress those millions into thousands. The sobering reality is that, unlike local objects, there are no historical precedents to lean on for interstellar threats. The small number of such discoveries means each new case requires building the playbook from scratch. Beyond the science, the implications ripple outward into society. The words "red alert" carry a weight that resonates beyond academic circles. Governments, space agencies, and defense departments inevitably pay attention when NASA elevates a potential hazard to this level. The specter of an interstellar strike forces urgent conversations about planetary defense, a field that has advanced dramatically but still lags behind in terms of readiness for the truly unexpected. Systems like kinetic impactors, which are designed to nudge asteroids off course, may prove ineffective against a body moving as fast and unpredictably as 3I/Atlas. The wider cultural effect is profound as well. People around the globe, upon hearing such news, inevitably confront their vulnerability in the face of cosmic forces. Civilization often operates under the illusion of control, but the approach of something like 3I/Atlas strips that away, reminding humanity of its place on a fragile planet in a vast, indifferent galaxy. The red alert has already triggered intense debates about preparedness, resource allocation, and the role of science in averting existential risks. The chilling prospect of impact is compounded by the sheer strangeness of the object itself. Unlike the rocky or metallic asteroids that populate our solar system, interstellar bodies could harbor exotic compositions. Some theories suggest 3I/Atlas may carry volatile ices or unusual minerals forged in alien star systems. If such a body were to collide with Earth, the encounter would not only be destructive but also scientific in ways we can barely comprehend. The material delivered would represent a direct sample of another planetary system, but at a cost too high to bear. In discussing the implications, one cannot ignore the cosmic perspective. For billions of years, Earth has been subjected to impacts large and small, shaping the course of evolution. Dinosaurs once dominated the planet until an asteroid delivered a global reset. That lesson lingers in the fossil record and the human imagination. 3I/Atlas revives that ancient fear, not as a relic of the past, but as a pressing possibility in the present. The knowledge that such events are not merely theoretical, but woven into Earth's geological history, magnifies the gravity of NASA's warning. The technological race is now on to refine the observational data. Radio telescopes, optical observatories, and even infrared instruments in orbit are being tasked with locking onto 3I/Atlas. Each pixel of data gathered reduces the uncertainty, constraining the arc it may follow. Yet in this race, time is the greatest adversary. Interstellar objects move swiftly, and once they retreat beyond the reach of our instruments, their fate relative to Earth remains sealed. There is also a deeper philosophical undercurrent to the event. Humanity has long gazed at the stars, wondering if we are alone, contemplating the immensity of the universe. Interstellar objects are tangible reminders that we are connected to that greater expanse. They are messengers from other systems, carrying the history of distant suns. But the arrival of such a messenger with the potential to destroy the cradle of humanity transforms awe into existential dread. The juxtaposition of wonder and terror is at the heart of the story of 3I/Atlas. Some scientists suggest that the object could fragment before ever reaching Earth, if indeed its path intersects ours. Interstellar travelers may be structurally weak, held together loosely after their long voyage. The immense forces of the sun's gravity and heat could shatter 3I/Atlas, turning a single catastrophic threat into a hail of smaller yet still dangerous fragments. This possibility complicates matters further. Smaller fragments could evade detection until the last moment, striking with little warning. The unpredictability of such outcomes underscores the seriousness of NASA's Red Alert. There is also the potential role of planetary defense experiments. Missions like DART, which successfully demonstrated the redirection of a local asteroid, represent humanity's first steps toward active defense. But against something as massive and fast as 3I/Atlas, such tools may be inadequate. The speed of interstellar bodies leaves little time for interception, and the energy required to deflect them could exceed our current capabilities. The chilling implication is that humanity might, for the first time in modern history, face a natural threat for which no ready solution exists. The significance of this moment lies not only in the physics of impact, but in the psychology of awareness. The Red Alert functions as both a scientific warning and a cultural mirror, reflecting back our fears and our resilience. It forces us to confront the possibility of annihilation while reminding us of the power of collective effort. Humanity has always risen to challenges by banding together, and the story of 3I/Atlas is already catalyzing collaboration across nations, institutions, and disciplines. As the days pass and more data streams in, the fate of 3I/Atlas relative to Earth will become clearer, but the underlying message remains. We live in a dynamic, unpredictable universe where threats can appear from the darkness with little warning. NASA's Red Alert is a wake-up call, not just about one object, but about the fragility of life on this planet. The terrifying data may ultimately reveal a safe passage, sparing Earth from calamity this time, but the mere possibility forces us to recognize that vigilance is not optional. This episode stands as a reminder that our survival depends not only on technology but on foresight and unity. 3I/Atlas embodies the dual nature of the cosmos, beautiful in its mystery, deadly in its potential. The terror it inspires today is matched by the determination it will ignite, a determination to understand, to prepare, and to endure. Whether it passes us by harmlessly or continues to tighten its grip on our collective fear, the story of 3I/Atlas has already changed how humanity views the heavens, reminding us that in the silence of space, danger can emerge without warning, and the responsibility to respond rests entirely with us. The announcement surrounding 3I/Atlas has opened a new chapter in how humanity thinks about space, risk, and the very idea of survival. While much has been said about the raw danger it poses, there are further dimensions that have not yet been fully explored. Angles that extend far beyond physics and astronomy into philosophy, geopolitics, human psychology, and even the way civilizations imagine their futures. Each layer deepens the gravity of the Red Alert, transforming it into something more than a simple scientific bulletin. It becomes an event that tests the structures we have built for knowledge, communication, and cooperation. The area worth examining lies in the unprecedented nature of NASA's warning. Rarely has the agency used such stark language. A red alert is not merely a caution, it is a categorical shift in the tone of communication. The choice of words reveals not only the seriousness of the data, but also a deliberate effort to capture attention on a global scale. For decades, NASA has been one of the most trusted voices in space science, and its decisions are shaped not only by empirical analysis, but also by a careful awareness of public response. Issuing a red alert over 3I/Atlas signals that the probability of risk has entered a threshold that transcends routine observation. It reflects a recognition that the situation demands widespread awareness, perhaps even preparation, beyond the usual circles of scientific discussion. This change in tone reshapes the relationship between science and society. It is one thing for astronomers to debate orbital calculations in journals, and quite another for a leading space agency to declare a potential threat of this magnitude. The shift pulls the conversation into the public arena, where fear, speculation, and misinformation can flourish. Yet this openness is also a form of responsibility. By sounding the alarm, NASA ensures that the conversation about existential risks is not confined to small communities of specialists. It forces governments, industries, and citizens to think about contingency in a way that has been largely absent outside of fiction and thought experiments. Closely tied to this is the way 3I/Atlas reframes our understanding of interstellar space. Until recently, the stars beyond our solar system felt unimaginably distant, their processes unfolding far outside human relevance. But objects like 3I/Atlas collapse that distance. They remind us that material from other systems does not remain isolated. Rocks, ices, and fragments ejected from alien worlds can and do wander into our neighborhood. The cosmos is not static. It is a web of exchanges, collisions, and migrations. That realization forces us to think of the solar system not as a sealed-off sanctuary, but as an open frontier exposed to currents we do not yet fully understand. The interstellar nature of 3I/Atlas also raises fascinating questions about what it carries within it. Every fragment of matter holds the story of its origin. Its isotopic ratios, its mineral content, even its molecular arrangements could reveal the environment where it formed, perhaps around a different type of star, under conditions alien to Earth. Were it possible to study 3I/Atlas up close, scientists could learn about planetary formation beyond the Sun in ways telescopes cannot capture. Yet this promise of knowledge comes entangled with dread, because the same object that might expand our scientific horizons is the one that could shatter our world. This juxtaposition of discovery and destruction makes 3I/Atlas unique, a cosmic paradox where knowledge and danger arrive together. Beyond science, the geopolitical implications of NASA's alert are vast. The threat of 3I/Atlas is not a local issue. If it were to strike Earth, no nation would be immune to its consequences. Yet the ability to respond through observation, modeling, or even attempted deflection rests heavily in the hands of a few technologically advanced powers. The red alert creates an arena where cooperation and competition collide. On one hand, global collaboration seems obvious. Pooling resources, sharing telescope time, and uniting engineering efforts to prepare possible interventions. On the other hand, the same scenario could breed secrecy, as governments consider whether to withhold information or technology in pursuit of national security. A threat of planetary scale exposes the tension between humanity as a collective species and humanity as a patchwork of competing states. This tension plays out in practical terms. Suppose one country develops a prototype deflection technology. Would it share this openly or hold it close as a strategic advantage? If a mission were launched to intercept 3I/Atlas, who would lead it, and who would bear the risks if it failed? These are not abstract questions. They cut to the heart of governance in an interconnected but divided world. The shadow of 3I/Atlas forces governments to rehearse scenarios where decisions must be made not for the benefit of a region, but for the survival of the planet itself. This is a profound shift in political imagination, one that very few institutions are prepared to handle. On the psychological front, the idea of an interstellar object on a collision course with Earth stirs primal fears. For much of human history, cosmic events were interpreted through myth and religion, comets as omens, eclipses as signs. Today, science provides explanations, but the emotional weight remains. The possibility of 3I/Atlas striking Earth taps into a collective memory of vulnerability. It reminds people of stories they have grown up with: asteroids wiping out dinosaurs, cataclysmic impacts ending eras. Even those who trust the probabilities and expect a near miss cannot fully shake the unease of knowing that cosmic randomness is capable of erasing civilizations. This unease is amplified by the way modern media circulates information. The term red alert travels fast, stripped of context, repeated in headlines and sound bites. While NASA's intent may be careful communication, the broader ecosystem of media thrives on amplification. For some, the news becomes an excuse for sensationalism, heightening fear to attract attention. For others, it breeds skepticism, with people dismissing warnings as exaggerated. The interplay between genuine scientific caution and public interpretation is itself a story of vulnerability, not to asteroids, but to the fragility of trust. Trust, in fact, emerges as one of the most crucial resources in a moment like this. If NASA's red alert is to have meaning, it must be believed. If the data suggests risk, governments must accept it and act accordingly. Yet trust is not evenly distributed. In some regions, suspicion of international institutions runs high. In others, scientific literacy is uneven, making people susceptible to denial or conspiracy. The challenge of 3I/Atlas is not only to understand the rock itself, but also to navigate the landscape of human response, where disbelief and panic can be as destabilizing as the physical threat. Philosophically, the object also pushes us to confront questions about fate and agency. The universe has always hurled material at Earth. Impacts are part of the natural order. But never before has humanity possessed the ability to foresee such events in real time. We stand in a strange position, aware of a danger that past species would never have known, yet uncertain whether we can do anything about it. This awareness creates a tension between fatalism and responsibility. Should we accept cosmic hazards as inevitable, or should we marshal every tool at our disposal to resist them? The existence of the red alert suggests that NASA leans toward agency. That knowledge carries the duty to act. Yet the enormity of the task raises doubts about whether action is truly possible in this case. The timing of the alert also intersects with broader debates about humanity's future beyond Earth. For decades, visionaries have argued that becoming a multiplanetary species is essential to survival. The threat of 3I/Atlas underscores this argument in the starkest way. If all of humanity remains confined to one planet, then a single cosmic event could extinguish everything. Colonies on the Moon, Mars, or orbital habitats would not guarantee survival, but they would provide a measure of redundancy. The red alert strengthens the case for accelerating these projects, not just as exploration, but as insurance. However, pursuing such projects is not straightforward. The enormous costs and technical challenges of establishing off-world settlements have long been barriers. Critics often argue that resources should instead be focused on solving Earth's existing crises: climate change, poverty, inequality. The appearance of 3I/Atlas complicates this debate. It suggests that neglecting planetary defense or space colonization carries risks that are harder to dismiss. In this sense, the object functions as a kind of mirror, reflecting the priorities of civilization back at itself. Do we invest in defense against unlikely but catastrophic threats? Or do we continue to allocate resources primarily to immediate needs? There is no easy answer, but the urgency of the question is now unavoidable. The scientific dimension also extends into deeper mysteries of astrophysics. If 3I/Atlas is truly interstellar, its path through our solar system could reveal new details about gravitational dynamics. Observing how it interacts with the sun's influence, how it accelerates or decelerates, could refine our models of celestial mechanics. Moreover, studying its spectral signature could reveal exotic chemistry. Perhaps it carries molecules not commonly found in our system, offering a hint at the diversity of planetary environments in the galaxy. In this way, the red alert is not only a warning but an opportunity, a fleeting chance to learn something extraordinary, yet opportunities are double-edged. To study 3I/Atlas requires time and focus, both of which are scarce in a context of potential threat. Astronomers must balance the pursuit of knowledge with the urgency of risk assessment. Every hour spent analyzing its composition is an hour not spent refining its orbit. The tension between curiosity and caution becomes part of the drama, embodying the human condition itself, the desire to understand even in the face of danger. One underexplored angle is the cultural and artistic response to such a moment. Throughout history, cosmic events have inspired creativity, from poetry about comets to paintings of eclipses. The announcement of a potential interstellar strike is certain to ripple through art, literature, film, and music. Creators will seize upon the imagery of a rogue object hurtling toward Earth, using it as metaphor for fragility, urgency, or renewal. In this way, 3I/Atlas may become not just a scientific subject, but a cultural symbol, representing the precarious balance between humanity and the universe. There is also the question of legacy. If 3I/Atlas were to impact Earth, or even pass close enough to remind us of the danger, what story would future generations, or future civilizations, tell about this moment? Would it be remembered as a wake-up call that spurred action, or as a warning ignored? The red alert forces us to think in terms of historical narrative, where present choices echo far into the future. The very act of documenting the threat becomes part of the story humanity leaves behind, regardless of the outcome. Education becomes another crucial domain. How should schools and universities address such a threat? On one hand, it could be seen as an opportunity to inspire interest in astronomy and planetary science. mobilizing young minds to think about defense and exploration. On the other, the prospect of catastrophe could breed anxiety, particularly among younger generations already grappling with climate change and other global crises. The way the story of 3I/Atlas is communicated to students will shape not only their knowledge, but also their sense of hope or despair. From a technological standpoint, the event raises profound questions about readiness. Do we have the capacity to detect interstellar objects reliably? Or was 3I/Atlas caught largely by chance? If the latter, what improvements are needed? The red alert may catalyze investment in next-generation observatories, infrared telescopes capable of spotting faint objects earlier, or space-based instruments positioned far from Earth to give a wider view. It could also drive innovation in response technologies, from faster propulsion systems to experimental methods of altering trajectories. Each step forward would be a response not only to 3I/Atlas, but to the general category of threats it represents. The appearance of 3I/Atlas underscores a theme that transcends science and politics: humility. For all our technological achievements, for all our mastery of Earth, we remain vulnerable to forces that operate on scales beyond human control. The red alert is a reminder that the cosmos does not revolve around us. We are one species on one planet, subject to the dynamics of a universe that existed long before us and will continue long after. This recognition is sobering, but it can also be motivating. It can push humanity to rise above short-term divisions and confront the shared reality of existence in a vast and unpredictable cosmos. Taken together, these dimensions show that 3I/Atlas is more than a passing threat. It is a catalyst for reflection across science, politics, culture, and philosophy. It forces us to ask not only what might happen if it strikes Earth, but what it means to live in a universe where such possibilities exist. NASA's red alert is terrifying, yes, but it is also clarifying. It reveals the contours of our vulnerabilities and the scope of our responsibilities. Whether or not 3I/Atlas comes closer than we fear, the lessons it brings are already reshaping the way we see ourselves and our place among the stars. The red alert surrounding 3I/Atlas has done more than jolt astronomers and officials. It has pushed the very boundaries of imagination about what it means to inhabit a fragile world. Much of the conversation has centered on probabilities, trajectories, and the stark mathematics of orbital mechanics, but there are deeper currents worth examining. This object is not only a celestial hazard, but also a lens through which human resilience, creativity, and vulnerability can be studied. One striking element of the alert is the way it reveals the infrastructure of planetary surveillance. Humanity has developed networks of telescopes, space-based observatories, and computational tools to watch the skies, but these systems were never designed with interstellar interlopers as their primary concern. They evolved to track predictable patterns of near-Earth asteroids, bodies whose motions can be refined with repeated observations across many years. An object like 3I/Atlas exposes the gaps in this infrastructure. Its sudden arrival forces us to confront how dependent we are on luck as much as on technology. That it was detected at all is remarkable. That it might evade full characterization before its decisive pass reminds us of how much more we must build. This inadequacy prompts an urgent reevaluation of priorities in space observation. Instruments capable of capturing faint, fast-moving bodies across vast regions of the sky are still scarce. Large survey telescopes like the Vera Rubin Observatory promise to change that in the near future. But the situation with 3I/Atlas demonstrates that readiness cannot wait for scheduled launches and gradual upgrades. What is needed is a fundamental expansion of monitoring capacity, perhaps even networks of satellites dedicated solely to scanning for such unpredictable intruders. This is not simply an academic exercise. The sooner such objects are spotted, the more options humanity has to prepare, even if preparation is ultimately limited to modeling and contingency planning. The technical challenge of rapid response also deserves attention. If a space mission were to be launched toward 3I/Atlas to study or potentially intervene in its trajectory, it would demand levels of agility and speed far beyond what current mission timelines allow. Most space missions take years of design, planning, and construction before launch. An interstellar object hurtling inward affords no such luxury. This mismatch underscores the necessity of flexible modular systems that can be adapted quickly, perhaps stored in readiness until an emergency arises. It points toward a future in which humanity must not only plan for exploration, but also prepare for defense. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on NASA's red alert about 3I/Atlas possibly striking Earth? We want to hear from you. Thank you for watching and see you next time.